We have alpha equal 1 plus square root of 5 over 2, and we try to find the floor function of alpha raised to 12th power. Of course, floor would take the integer part of a real number. Okay, so here alpha, if you noticed, it is related to the golden ratio. This value is approximately 1.618. Now, 1 plus and minus square root of 5 over 2 are the two roots of this quadratic equation. Now, surprisingly, we're going to use linear recurrence sequence to solve this problem. So here, if you're familiar with the linear recurrence, this quadratic equation is the characteristic equation for the following sequences. That is, the sum of the previous term gives the next term. Okay, so very similar to Fibonacci sequence. Now, the general solution, because we have two roots, so general solution is going to be here. Okay, and the same thing is true for Fibonacci sequence, but here, in order to simplify or apply what we're trying to find, which is alpha, the first value raised to 12th power, we would like to take A and B equal to 1. In other words, we are interested in that sequence. So in that case, A and B usually is determined by the initial values, like what is A0 and A1. All right. So if the capital A equal to 1, B equal to 1, right? So we're gonna have A0 equal 2 and A1 equal 1. Now, from this initial value, with this recurrence relation, we can find the remaining terms, A2, A3, A4. So each term is just the sum of the previous two terms, right? A5 until A12. All right? Okay, that's good. 322. We need to know. So what is A12? According to the recurrence relation, an is equal to this raised to the nth power. So A12 is going to be alpha here raised to 12th power plus this number. And notice that this is a negative number, but it raised to 12th power is become positive. And this number is actually about negative 0.618. So when you raise to 12th power, it's going to be less than 1. So the value is positive, but less than 1. So which means the first part, which is alpha raised to 12th power, is going to be 321 dot something, right? Some fraction part. So in other words, we have the second term, right? Here is a positive number and is less than 1. So we have the integer part of alpha raised to 12th power is going to be 321. That's the answer. All right. Of course, you could also use some other methods, like for example, reduce the power and other tricks to find out, alpha raised to 12th power. Okay. So hope you enjoy the video. Please like and share.